Okay, so the big thing with division of complex numbers is it's not actually written as division. With division of complex numbers, it's actually written as a fraction. So when you see division, it really just looks like a fraction. So it'd basically be something like that. Okay, and again, we're not, even though it's division of complex numbers, we're not going to do division to simplify this. We're actually going to do multiplication. So if you think back to when we had fractions and division, how you would keep it, change it, flip it, you'd multiply by the reciprocal. It's not quite that one, but it's going along those same lines for this thing. So, and here's the big thing with this one, how this sets up, is that you cannot have I in the denominator. Okay, so that's the big thing with complex numbers is they say, all right, you cannot have I in the denominator, just because of, honestly, this is kind of some leftover stuff from way back in the day before they had a lot of good calculators that would do stuff. We've got enough calculators now that this is probably not a big deal, but it's still kind of one of those things that they're hanging on to a little bit, um, for everything that's here. So here's what you're going to do. So to eliminate I from the denominator, or if you're Perry the Platypus and you're fighting Doofenshmirtz and maybe a denominator, as you're going through this thing. So to eliminate I from the denominator, basically here's what you're going to do. You're going to multiply by the conjugate of the denominator. Okay, and if you may be asking, what is the conjugate of the denominator? When it talks about the conjugate, all you have to do is with whatever expression you have, you just change the positive negative sign in front of the I term. And actually, the last problem we did with multiplication, with the part we were doing yesterday, was actually a conjugate problem that we were doing, and we'll show you that one. If you don't have that right in front of your notes here, let me show you what that one was yesterday. That was a foreshadowing moment of what we were doing. Because here's what we have. Yesterday, the very last problem that we did was 6 plus 5i and 6 minus 5i. And again, that's where, again, you've got the same numbers where you've got one that's positive, one that's a positive 5i, the other one's a negative 5i. And if you multiply two things that are conjugates together, then it winds up that the terms in the middle, when you do the full method, they will always cancel each other out. One of them's going to be a positive, the other one's going to be a negative. These two things cancel. You've got your I squared term that will change to -1, and now you've got just a regular whole number, and there is no imaginary, there is no complex part of the answer that goes with this one. And so that's the whole one. So when we talk about conjugates, and we'll actually talk about this one again, probably in about probably right around spring break ish. We'll talk about conjugates again on this part of it. But the main thing is that you just change the sign in front of the plus or minus term. It's in front of the I term. So for this problem, here's what it would be. We've got 3 plus 4i over 2 minus 5i. And so what we're going to do is we're going to multiply it by 2 plus 5i. And whatever you do on the bottom, you also have to do the same thing on the top. Okay, and the way these problems are written, they will not put parentheses on these, but you basically can go back and put parentheses around all these different parts and expressions. All right, so if we do this in two parts, actually I'm going to do the top part in blue, and then we'll do the bottom part in red, just so we can kind of keep it separated. All right, on the top part, there's not really a shortcut on the top part of it, because on the top part, it's going to be 3 times 2, and then 3 times 5i, which would be 6 plus 15i. And then if we do 4i times 2 and 4i times 5i, 4i times 2 is 8i, 4 times 5 is 20, and I squared. Okay, and then do the simplifying you can do. The 6 is good. We've got 15 plus 8, so that would be a 23i. And again, with the I squared part of that one, that's where you would replace the I squared with negative 1. So that's 20 times negative 1, which would make that a negative 20. And then you've got 6 minus 20, which would just be negative 14 plus 23i. Okay, so that part of it still, and again, even though it's a division problem, what they call division, which really is just a fraction, it's still just multiplication. You're going to multiply the numerators together to get an answer. Then we're going to do the same thing on the bottom. But on the bottom, again, it's basically for this part of it, you get to do the shortcut. Because if you multiply by the conjugates, the shortcut is it's not the full method. It's going to be the FLA method. Because the O and the I terms, if you do the distributive property on this one, they always wind up canceling each other out. So if we do this one, so again, if you want to just kind of, we'll go separate piece of paper on this one real quick. So we're going to do the FLA shortcut. So we're going to do the first times the first, so it's 2 times 2, which is 4. And then we're going to do the last times the last. So we're going to do negative 5i times positive 5i, which is negative 25i squared. And if you don't believe me, here we go. We'll show you how this works with the FLA method, not the full method. So if you do 2 minus 5i times 2 plus 5i, 2 times 2 is 4. 2 times 5i is 10i. We do negative 5i times 2, that's a negative 10i. And then we've got negative 5 times 5, so negative 25i squared. And with conjugates, every single time, these two terms in the middle, you've got 10 minus 10, will always go to 0, which basically just knocks those two things out. So with conjugates, you still do the full method, but there's a shortcut that it's really just the FLA method. You do the first times the first, you do the last times the last. So basically you do 2 squared and you do 5 squared. And that, again, these two terms in the middle always cancel each other out, which just means it's the first ones and the last ones multiplied. So y'all get to cheat a little bit. You could do a shortcut here. You don't get to do the full method, you do the FLA method. You get it there. Okay, so then, sticking on the bottom part, again, you're going to take out the I squared, replace it with negative 1. That means it's going to be 4 plus 25. And that makes it 29. Okay, and then that's the answer that you're looking for. Okay, now here's where Math Excel is inconsistent with some things. Now, homework-wise, if we're doing this on a test, I'm okay with this answer. Sometimes with Math Excel, they will actually take this problem and break it up into 2 parts. So they may make it negative 14 over 29, and then plus 23 over 29i. So you just have to kind of watch through Math Excel to see what format they want. In that case, this would be a great problem on these to click on the view an example just to see if they want the problem written as 1 fraction or if they want it as 2 fractions. Again, for me, I don't care. Either way is fine. Math Excel gets a little picky sometimes. Sometimes they want it this way. Sometimes they want it this way. I would say this is kind of our default answer. Just because over here, if this had been 28 on the bottom instead of 29, then you could have simplified this fraction. So that's the big reason they do that. But again, sometimes they'll let you leave it this way. Sometimes they want it this way. You just have to kind of simplify as much as you can as you go through these. Okay, let's do another one of those. Make sure everybody's okay with it here. So if that was example 1, all right, here we go with example 2. Okay, and again, numerator really doesn't matter in this case. Everything is based on the denominator. So what we're going to do, if this is the problem, we're going to take that same problem we've got, and we're going to multiply by the conjugate. So instead of 7 plus I, we're going to multiply by 7 minus I. And again, over here, even though they don't have it written with parentheses, you can put parentheses there. With just the one term, we don't need the parentheses. So we can kind of leave that one off. Okay, up here, not really much to do. It's 4 times 7 for 28. It's 4 times negative I, so it's a negative 4I. Okay, bottom part again, you get to do the FLA shortcut. So we're going to do 7 times 7 for 49. We're going to do I times I, which is I squared, and it's a negative I squared. But again, with the I squared term, we can take out the I squared term, replace it with a negative 1, so it's minus negative 1. So it's really 49 plus 1. So your denominator is really 50. Okay, so top part in this case is easier because it was just a little distributed property. Bottom part, we had to do our shortcut for this one to get it to here. And because this is 50, if it was 28 over 50, could you simplify that? Okay, so that's where they want you to kind of look at it. Is that if you've got the two parts that's here, they want you to go ahead and kind of break this thing up instead of one big fraction over 50. Because if it was, 28 over 50, we could simplify it. If it was 4I over 50, we could simplify that one. So this is where they want you to go ahead and break this thing up. It's like two separate fractions. So then you can actually simplify each piece of the fraction to kind of get it there. So if we've got 28 over 50, we can divide them both by 2 and make that 14 over 25. And then 4I over 50, divide them both by 2, we can make that 2 over 25. Okay, so that would be one answer. And again, sometimes with Math Excel, they're very, and I'll be honest with you, this is where it's very inconsistent in Math Excel. They may let you leave the answer like this, or they may go, oh, since that's a common fraction on the bottom, you could also turn around and rewrite it so it's like this. So and again, I'll just giving you that heads up, that warning. It's very inconsistent for this section of Math Excel. Sometimes this is okay, sometimes this is what they want. So just use that view an example button so you can at least scroll through the answer, see how they set it up, and see how they want the answer, and they will tell you whether they want the answer like this or like this based on how it's set up in the homework. Okay. All right, here's the little, here's where we spin off the division part of it just a little bit. We're still working with the complex number part of this one. The other couple things they'll throw at you is may have you do some factoring in this case. And if y'all remember on the last test, we were doing the difference of perfect squares. And we said that there was no shortcut for the sum of perfect squares. Basically, I lied. With real numbers, there is no shortcut. With imaginary numbers, there is a shortcut, but we weren't there yet. So I was like, okay, we're just not going to worry about this one. So if it's a sum of perfect squares, so on the last test, we knew if we had x squared minus 81, we would make this x plus 9 and x minus 9, right? Because we had 9 times 9 for this thing. So the difference is on this one is, so last test, that was our answer. Because this was x times x. This was 9 times 9. And as long as it was a difference of perfect squares, we made one a positive, one a negative. Okay, so here's where we're going to change it just a little bit. So difference of perfect squares, we had this shortcut. If we change this to a sum of perfect squares, oh, hold on. Everybody don't get blown away here. Because if we do a positive times a positive, that would make that an 81. But then if we did the full method, just to show you why this wasn't work, why there's a different one for this one. If those were both positives and we got the 9 times 9 to get 81, the problem is if we do 9x and 9x here, that means in the middle it would have to be 18x for that to work. Okay, so here's where we get to use our imaginary numbers. Here's where we get to pretend just a little bit because they're imaginary numbers. So if it's a sum of perfect squares, we do it just like we did if we were doing a difference of perfect squares. The only thing we do different is we put an I with that number at the end. So if it's a difference of perfect squares, it's real number, positive and negative 9. If it's the sum of perfect squares, it's still plus and minus, but now it's going to be an imaginary number if we did that one. Because again, now these two things are conjugates, correct? Because we didn't even really talk about that before. But if those two things are conjugates and we multiply them together, we've got x times x for x squared. We've got x times 9i, which would be a negative 9ix. This one, if we multiply these together, that's a positive 9ix. We get a negative 81i squared. And again, you got a plus 9 minus 9. That goes away. We've got x squared. We take out the I squared and make it a negative 1. That makes it x squared plus 81. Okay, so there's the thing we get. So again, I kind of lied to you a little bit because y'all were asking, what if it's a positive? Well, again, there's no real solution to the factoring on that one, but we can do imaginary numbers, so we had to kind of wait until we knew what the imaginary numbers were there. Okay, and again, that kind of lends itself into the solving because if you had to factor, again, just do like difference of perfect squares, one positive, one negative. Just put the I term there. If you're solving, if we had to take that same thing we had to solve in this case, where you got x squared plus 81 equals 0, you can do this in a couple of different ways. You could factor it off to get to this part of it. You also could do like with the perfect squares we were doing, that you could subtract the 81 from both sides. And then we would square root both sides. So we get a plus and minus. Square root of 81 would be 9. And again, the only difference is if it's got the negative in there when we're solving and square rooting, we just had to put the I term at the end to let us know that that was not a real number with 81, but it's an imaginary number. Okay. And again, you could do the same thing back here, that if you were like, well, why couldn't we just factor like we did here? If it's x squared plus 81, we know it's this part. Why can't we just take that thing and set that equal to 0? Because you could, because then you could do x plus 9i equals 0, and then x minus 9i equals 0. When you do that, that makes that a negative 9i. When you add this over, you get a positive 9i. So there's your plus or minus that you get here. That's also the same thing that you've got here. Okay, so it doesn't matter how you want to see it. Most people kind of like doing it this way because they're like, I'd rather just move it over and square root it, which is absolutely fine. But they're also saying, all right, well, if you're okay with the factoring shortcut that we have, you can also set each factor equal to 0. Okay, well, and there's not going to be a lot of those questions because, again, that's just kind of a spin-off of still solving with our square roots that we were doing here. But they're just throwing it out there of giving you an option to know that, okay, if it's the sum of perfect squares, we actually have a shortcut with imaginary numbers. Okay, one more thing, and then we'll show you some things we're going to use a calculator on. Okay, and then and this doesn't really fit in with division. It's more of just working with imaginary numbers still again for this one. So this is where they're going to ask you just to simplify some expressions. So they'll tell you to simplify. But the one thing they don't really tell you is that you need I in the answer. But again, we're in imaginary numbers section, so it's pretty much going to be that way that we're going through this one. Let's make this a plus problem. So let's do 6 plus the square root of 4 negative, and then plus 9 plus the square root of negative 25. Again, for this part of it, they just tell you just to simplify. And this is one of those where basically you've got to know that you have I in the answer for this thing. Okay, so for your square roots, if it was square root of 4, we know that would be 2, correct? But because it's square root of negative 4, it's not 2, it's 2i. Okay, same thing on the second one. We've got 9 plus, well, the square root of 25 would be 5, but because it's square root of negative 25, that would be the I that we have to put in there. So we've got to take out these negative square roots first to get our I term we've got. And once we've got the I term, then it should either be addition or subtraction or possibly even multiplication. In this case, it's just addition. So then it's 6 plus 9 with the whole numbers. Sorry, with the real numbers. So 6 plus 9 is 15. And then you've got 2i plus 5i, which would be a plus 7i on your imaginary numbers. Okay, so again, when they ask you to simplify, you've got to put whatever square roots they give to you, you got to convert those to put them in terms of I. And then once you do that, you either add, subtract, or multiply. Again, I don't think there's any division in that one. I think it'll all be just either multiplication or addition or subtraction. Okay, and then the last thing, which is all calculator for the most part. Okay, because there's a way to do this one by hand, but let's be honest, nobody's going to do it because we've all got calculators and we're going to lean on our calculators. So we're going to show you how to do this with your calculators. It's going to ask you to simplify powers of I. And then all you have to do for those is you're going to take whatever power of I they give to you and divide it by 4. So again, use your calculator. Take whatever power they give to you, divide it by 4. And what we're going to do in this case, everything is based on the remainder. So the remainder tells what your answer will be. So the remainder is not your answer, but it's going to tell you what the answer is going to be for these. Get just enough room to get this one here. Oh, actually, let me just put this on a separate page. I'm trying to squeeze it in. Let me put this on a separate page here. Not even trying to make it really tight. Okay, so basically we've got this one. So we're going to divide numbers by 4. And again, we're talking about remainder with a calculator, because if you do it without a calculator, it's a different set. Okay, so if your remainder is 0, or if there is no decimal in your answer is going to be 1. If your remainder is 0.25 on the calculator, your answer is I. If your remainder is 0.5, your answer is -1. And if your remainder is 0.75, your answer is going to be negative I. Okay, now, and if you go back to this one, the old, and you don't have to write this down, but the non-calculator answer, if you did this by hand, I'm actually put over here to the side. But again, we're going to be honest with you in this case that, I don't think anybody's going to be doing this one by hand. If you do, that's great. If not, that's fine too. If it's a non-calculator reminder, that would be 0. This would be a remainder of 1. This would be a remainder of 2. And this would be a remainder of 3. But again, I don't know if anybody's going to do this one by hand. But if you were doing this by hand, if your remainder was 0, the answer is 1. If the remainder is 1, it would be I. Remainder is 2, it's negative 1. Remainder is 3, it's negative I. All right, so here we go. Here's where we get to practice. Let's do I to the 63rd power. Okay, again, we're going to go with the calculator remainder. So we're going to cover up the part that's in red over here. So all we're going to do is we're going to take 63 and we're going to divide it by 4. We get 0.75 for the decimal for the remainder because I go 15 times, and again we got 0.75. So with 0.75, it says the answer is negative I. So for this one, your answer is negative I. And that's it. That's all you have to do. So somebody made another different number that's not 63. 93? All right, so we're going to take 93 divided by 3. That is 30. Wait, hold on. 93 divided by 4. My bad. That one is 23.25. So the decimal remainder we get is 0.25. 0.25, the answer is I. Question. You always divide by 4 every single time. All right, somebody else, give me another power. I heard somebody say something else earlier. What do we have?
26.
26. All right, I have the 26 power. So again, we're going to take 26 divided by 4. Answer is 0.5. 0.5, the answer is negative 1. Okay, so again, any power, just take whatever the power is, you divide it by 4 on your calculator. Again, if it was 40, you take 40, divide it by 4. That one, it comes out to be a whole number. There is no decimal answer for that one. So if it was, to the 40th power, that was a 0 remainder, have a remainder. So then your answer basically is 1.